Question says, calculate the delta H reaction below given the other two reactions. So this is a Hess's Law problem. So what we have is we have carbonic acid forming formaldehyde and oxygen. And we're given two reactions with carbonic acid forming water and CO2 and formaldehyde burning in the presence of oxygen to form water and carbon dioxide or carbon dioxide and water. So this basically, if we know something about these two reactions may tell us something about this reaction. Now in a chemistry textbook, there's a good chance these two reactions will tell us something about this reaction. Set enthalpy as a state function, if these two reactions combine to give this reaction, then all we have to do is combine their delta H's, and we can then find the enthalpy of this overall reaction. But here's the trick. You can't just simply combine them by adding them together if they don't add up to give you this one. So we need to find a way to make these two add up to do that one. So I'm going to call this one 1, and I'm going to call this one 2. So when you combine chemical reactions or you add chemical reactions, you literally just write all the reactants on one reactant side of a larger reaction and all the products on one product side of a larger reaction. When you're trying to do Hess's Law, what you're looking for is what's unique about this reaction and what's unique about this reaction in the overall reaction. So if we look here, I see carbonic acid here and I see carbonic acid in the overall reaction. I then look for this one. I do not see carbonic acid here. There's no H2CO3. So I know that in my overall reaction, the carbonic acid is going to come from this reaction. The second thing I want to look at is the stoichiometric coefficient. There's one carbonic acid here and one carbonic acid here. So I don't need to actually do anything. So I can just simply keep reaction 1 as H2CO3 solid yields H2O gas plus CO2 gas, and the delta H of the reaction is equal to positive 51 kilojoules. All right, I could just leave that alone because there's the right stoichiometric coefficient and it's on the right side. Now let's look at the bottom one. The bottom one, I notice I have formaldehyde here, okay? And if I look up here, I see that there's formaldehyde. There was no formaldehyde in this one. But if I notice up here, I have formaldehyde as a product, and over here I have formaldehyde as a reactant. So what I need to do is I need to reverse this. So I want to reverse 2. I should have mentioned there's one of these and one of these. So since there isn't more than one of these, I don't need to multiply by 2 or 3 or whatever. In this case, I just need to reverse it. So let's reverse this. Reversing a reaction just means write the products as reactants and the reactants as products. So I'm going to put H2O gas plus CO2 gas yields H2CO gas plus O2 gas. So I literally just reverse this by writing these as my reactants and these as my products. These were originally products, these were originally reactants. So that's reversing. What happens to the delta H for the reverse reaction? Well, if it was negative 38 kilojoules here, I want to make it positive 38 kilojoules here. Because I reversed it, I have to reverse the sign of the delta H. Now, I need to add these reactions together. Adding reactions together is literally just writing all the reactants on one reactant side and all the products on one product side. So H2CO3, the first one, plus H2O, I should have put a solid here, gas, this one, plus CO2 gas, this one. Now I've got all of them. Yields H2O gas plus CO2 gas plus H2CO gas plus O2 gas. Now I want to cancel out anything that's on both sides. So the first thing I notice on both sides is water. Okay. The next thing that I notice on both sides is carbon dioxide. The rest of them are only on one side. Okay, so therefore we have to keep them. So I rewrite this. H2CO3 solid yields H2CO gas plus O2 gas. And for the examples that are chosen, it's common that things cancel out like this. If I added these two reactions together, I can add their delta H's. So I just take 51 plus 38, which is delta H reaction equals positive 89 kilojoules. Now if I look, this reaction is exactly identical to the reaction we were trying to find. H2CO3, okay, carbonic acid, yields formaldehyde plus oxygen. I found the delta H of this reaction, so therefore, of course, I found the delta H of this reaction. Said another way, I answered the question that was asked of me.